Welcome everyone, and thanks for joining. This session we are going to explore how a FlowerTune simulation works. And first, an introduction about me. I choose learning AI ML one step at a time as a presentation to myself, as my background, as you see in my description, is of a DevOps engineer. So as a DevOps engineer, our goal is to bridge the gap between development and operations, and we have deal with coding. We often have to deal with containerization. We often have to deal to continuous integration pipelines, deployments, and we have to support the developers. So it's very important for us to understand the infrastructure of the present and also the infrastructure of the future. And as we are also using LLMs, and of course we are using LLMs locally for security reasons, especially when we have to perform syntax correction of code bases, or simply to have help while working. As DevOps engineer, we are working often in operations, so we don't have always the capacity to work on development tasks. And that's the main reason why I was very much interested in the coding challenge in the Leaderboard, and also to experiment with small models. So small models that you can run eventually on edge devices, on your laptop, and that are also small in terms of size. So I began experimenting in artificial intelligence and machine learning around 2016, first experimenting with RNNs, LSTM, mostly for text generation. Later, with the early release of GPT models, transformers, I became very interested in the whole open source community and all the development that are bringing us a lot of innovation today, as we see with the recent release from DeepSeek and also the development of small language models that is very interesting. So we can move next about the topics. So why Flower? So we are focusing on in improving the research and the development capabilities of small individuals, small organizations, individuals like me that can contribute despite not being fully active in the AI ML research community. So we are going to highlight comparative results between different large language models and smaller models like we have seen with Qwen. Then we are going to discuss about the dataset. We are going to explore a bit the dataset that is used for the code challenge and how we chosen this model. What are the reasoning why we have chosen a small model. Then we are going to see an overview about the optimization parameter that we have used during the training process, so for supervised fine-tuning. And then we are providing a breakdown of the infrastructure setups and costs to see how this model has performed also in terms of costs. And then we are going to present the performance results on the benchmarks. So we have MBPP, that is mostly Python challenges, human eval, that is a mixture between different kinds, and we have JavaScript and C++ as a kind of task. So we are going to explore why Flower and the core concept of federated learning. So most of the people that are here already know how Flower works, so we are not going in depth in this, but we are going just to introduce the concept. So in traditional machine learning, you typically require centralized data collection, where all data is sent to a single location for training. And this approach, unfortunately, can be inefficient, can be costly, and can have a significant risk with privacy. Federated learning works in a different way. So the data is distributed across multiple nodes or devices, and each node trains the model locally on its own private data. and sends only the model updates back to the central server. So we can go directly to the second explanation of this, how the simulation engine works, because it's important to say that Flower is suitable for distributed federated learning, but you can also run a simulation on a single node. And I found that very useful and when experimenting, especially given the possibility that we have right now with small language model that you can run even on consumer devices and GPUs. So we have, as a first step, the Flower datasets that download and partition and preprocess the datasets for the distributed training. And this step is crucial to ensure that each simulated client has its own dataset segmented. Then we have PEFT through the PEFT library for parameter efficient fine-tuning that allows to fine-tune a small subset of the model parameters. This is done for save time and resources. And then you have finally the process of LLM fine-tuning, that we are going to simulate a federated fine-tuning setup, and we are going to mimic real-world distributed training where multiple nodes are going to contribute to the model updates. And finally, the final output is the PEFT adapter. After fine-tuning, we are going to produce this PEFT adapter that can be used for inference and evaluation. So those are basically the components of the Flower simulation engine. And now I'm going to introduce some that I've made for the FlowerTune LLM leaderboard on different domains that I've done in my spare time to explore the framework. So I started at the very beginning with the 7 billion parameter model, the Mistral. I've been continuously interacting with the Flower community on Slack in order to get started, have suggestions. So I'm really thankful to Jan who has suggested me at the very beginning to try out an instruct model instead of the one that we are trying that was the baseline. This has given improvements in the average. The communication costs still high considering the model size. This had a rank of 3 in the leaderboard. This is in the medical domain that is kind of challenging. There are many different question and answer pair in the dataset that can be really challenges. And I've seen that there is also in the first place, a very good contribution that has been also very useful to overlook about some optimization techniques that we are going to see after. I wanted to try it at the same time for doing a comparison about 2 models of the same size. Also the Qwen2.5 7 billion parameters that rank 2. Here I have used different hyperparameters, but mostly roughly the same kind of setup. Probably there is only one small change in the target modules in the layers, but you can find the source code that is available in the FlowerTune main page, the LLM leaderboard. Then I want to try that is not a transformer model. It's a new model that has been introduced a few months ago. That was recalling me my first experience with text generation with RNN LSTM. At the time, this kind of architecture had some limits because it was not leveraging the attention mechanism. With long context, I was not performing well, but it was still promising, and I discovered that it has been released recently on Hugging Face with research by NXAI. So I decided to just to give it a recall to what I was doing 10 years later, just to trying out the performance, and was despite the average results are not very high. That's really promising, considering that it's not a transformer model, and I noticed that it's very fast during the inference. So the evaluation was quite fast to run compared to the other models. Despite the performance are not really like that, that's probably a model that can get more attention in future. Then the Microsoft model, the Phi4, that is a 14 billion parameters model, so a bit bigger. This has been a challenge on a single machine. So I had to choose a bigger GPU with more VRAM in order to achieve this. And here the results are very good. So we were able on the NLP challenge to get 55.64%. And this is ranked at the second position in the challenge. And then finally, the model that we are going to focus today is the Qwen2.5 encoder 500 million parameter instruct. So it's instruction fine-tuned in the code domain. And this has been ranked first, and we can see the communication cost just 8.9, roughly 9 gigabyte. And the average, for considering that is a very small model, the 34% is absolutely really promising. So we can go next about the dataset that we have chosen. And here you can see a link for the code submission where you can see also the baseline. So about the dataset is an instruction dataset where you have the instruction, the input and the output as a feature. You don't have additional labels that could have been used in distributing the data across different nodes, like a label describing the language, the programming language, or the kind of challenge could have been usable. But anyway, we use this in 20K samples. In this strategy, we are going to use 10 nodes. They are simulating 10 nodes, so the total number of node partitions. So this is 10K that gets 4,000 total number of training samples. That's only 2 clients. That is 10% of the simulated nodes. So the fine-tuning process on only 4,000 of those samples. As by looking at the dataset, I've seen that the question of answer pairs, SOMA, are really challenging, even for human beings. So I decided to choose a model, a small model, but I decided to choose a model that was already instruction fine-tuned on coding tasks. So as I already had experience during inference and fine-tuning with the Qwen models, I found very good quality code tasks. So I decided to go with this. Also because it's a small model and it could be very interesting also to trying out converted merged with the base model, converted quantized in the GGUF format, and to try to run it on edge devices or without a GPU for inference. And it has a 32K context length, and you can find more details about how the layers are structured for this kind of model by looking at the Hugging Face page or the research paper. So we are going then to see the hyperparameters that we have chosen to fine-tune this model. And here you can see the link of the Qwen2.5 coder family. So for this setup, we have chosen to use a mixed precision setup. That main goal to improve both the performance of memory efficiency and also the total time of the training. So first, floating point 16 is a format that is designed to reduce memory usage and to increase speed. So it has the same 8-bit exponent as FP32, and that means that it can handle a dynamic range of values, but it uses only 16 bits in total. So this allows faster computations. For operation, anyway, for operation like matrix multiplications, we use TF32, flow32. That is been introduced by NVIDIA Ampere GPUs. So in this case, if you are using an RTX GPU, this is going to be supported. And it also uses a 8-bit exponent that provides a good balance between precision and performance. And finally, we applied also Flash attention V2. Flash attention V2 to optimize the attention mechanism that is helping to provide speed and memory efficiency as well. And for the optimizer that is using during the super process is the choice was paged Adam W 8-bit. That is a memory efficient version of the Adam the W optimizer. So it uses 8 precision as well for certain operations. So we can move next. So yeah, talking about previously, I was mentioning another submission in the medical challenge that has been using this technique. So this DORA, that stands for distributed optimization and rank adaptation. That is a new technique and a new approach. That is, in this case, is targeting the specific modules like down project, gate, up project, O project, and QKView project that are key components in the transformer attention layers. So the configuration is including rank that is set to 32 to control the degree of the parameter adjustment, while alpha is set to 64 that scales the optimizer learning dynamics. So those optimization, I found them to be effective because before trying DORA, I tried with LoRa, and I've seen an improvement in accuracy. So you can see below a link to the paper if you want to learn more about this. Then for the training setup, we chosen a batch size of 8 and 10 steps per round. And how it works that the simulation starts the fine-tuning in rounds in total. You can configure that parameter is possible to be configured, not the number of nodes, but the number, the fraction fit, the number of rounds is something that is valid for the submission that you can change. So in this case, you have a small percentage of the clients that are participating to the round with a fraction fit of 20%. And the strategy is the default one that is the same as the baseline for is fed average that is useful for updates from the client. Then, as said before, we are going over rounds, but with the cousin annealing scheduler, as this is the same as the baseline, as the implementation that as is provided in the examples. So the learning rate, I just made a small change to reduce a little bit the range because before the minimum LR was I think 1E minus 6. I just changed that a little bit. I found some improvement in the accuracy and for the training strategy as before, we used the federated average, and for the step LR is constant, so it's always the same per round for each node. And now we can go to see finally the evaluation results. So I also put a link of the code contribution here. It is the same that you can find in FlowerTune and Leaderboard. So for the first task, MBPP, the model performed 25.80. 3781. As you can see, the performance is improved for the JavaScript. That could make it a very good JavaScript Pocket companion, and for the C++ as well. So that's very good results, I think, for a model of this size. And finally, about the costs, how much we have spent for this experiment. So in total, I can tell you that for the experiments has not been very expensive. Of course, there have been a lot of work development, so I spent some time and some money in computing in order to learn all this process. But the process itself, the training process itself, if we are going to exclude the dataset download, the package installation, the provisioning of the instance, has been going really, really fast with this kind of model. So I chosen a GPU that could be comparable to a consumer GPU in terms of memory and VRAM, and maybe also for the architecture, because I think that most of the RTX NVIDIA GPUs are supporting the precision that we have used this. So this could make possible for everyone to start experiment by their own, even with consumer devices. Or as I did by renting a VM, like I did with Kudo Compute, that is offering very good solutions, also leveraging on underutilized compute. The training simulation cost, so we can see here the breakdown with all the components, how much they costed on Kudo Compute. And as I said before, those are the costs on the fine-tuning, without the time taken for the download, without taking in account the network costs for downloading the datasets and the model weights. So this is just compute time for the training, and the model has been trained in 32 minutes and 4 seconds with a total price of 18 cents. So we are close to the end. So the first takeaway is that model size, it really looks like the model size isn't everything, that the Qwen2.5 coder billion parameter model, despite being small, can surpass much larger 7 billion parameter models with proper fine-tuning. Then, that we achieved this efficiency used mixed precision, quantization, and federated learning. Also, the way the data is distributed, I think that played a role in probably in getting the model generalized better on unseen data. And then I just encourage everyone to join the challenge, to contribute to the FlowerTune LLM Leaderboard, to experiment with the Qwen model, with the open source model that you can find, because participating in challenges can really drive innovations, and there are many collaborative opportunities to advance in open source AI that we have right now. Also, to keep it ethical, to keep it safe, it's very important that everyone contributes, not only the researchers in the fields, the users, the developers, everyone who contributes in open source. So we can say 90% smaller than 7 billion parameter models that achieve a comparable accuracy. We reduced the communication cost also about 90%, which is very important, considering that in a real scenario there are going to occur communication costs between nodes and clients. And this is going to be very costly if you are going to go large scale. And keeping that small is very good result. And yeah, of course, these outcomes demonstrate the potential on how efficient federated learning can be. So thank you very much. If there are some other questions, yeah, I'm here.
Well, thank you, Massimo. I think this was super interesting talk, and I really like the way you break down all the details from all different angles about your submission, like including the costs and the hardware you run. I have one question. What around how much fine tuning and basically how much tweaking of hyperparameters you had to do to come up with this, best best entry in the code challenge? Like, did you run, let's say, 10 experiments with different hyperparameters and different settings, or are we talking more about dozens of experiments?
Uh, it,
Let's say
it, it,
ballpark.
yeah, it took a while to experiment. So it's the 7 billion parameter models at the very beginning, I found really hard. And then at some point, I thought that maybe it should have been better to start to experiment, and also to do some to add the evaluation during the training. So to use an evaluation data set or the evaluation split. In order to that could have been improvement experiment. That the advantage of running a small language model in this case is the fast that is very fast. So if this can run in 30 minutes, then for me it has been only, for instance, okay, run the thing, then trying out get this higher, get this lower, try to experiment with the rank that was important for the size, for the communication cost as well, to experiment with not exceeding the communication cost that is most important for bigger models, but also for smaller models to keep in track the communication cost. Then I've been reading a lot of open source code, so I was very interested when the small LM2 came out from Hugging Face. I was seeing how they are doing the fine tuning, the optimization parameter that we were using. I think that I taken the page at Adam Liu from them. And also for other things, it's all it's all open source interaction. So you basically watch other people work and you try to iterate and to put the things together. And this is something that we do on a daily basis as DevOps engineers when
Yeah.
putting as a generalist put the things together.
Okay, cool. Well, great. Maybe there are some other questions from the audience, or maybe Jan. I think I see Jan Gao is in the call. He's the mastermind of the leaderboard. I don't know if you have some questions for Massimo. Maybe you all have already interacted, so maybe there are no more questions, right? Or maybe William, you have some questions, or anyone else.
Yeah, I just have a general question. By the way, thanks for the great talk and also the contribution to the leaderboard. So given your experience on the leaderboards, do you have any like suggestions or tips to other participants?
Well, for the developer experience, maybe adding a more detailed tutorial on how to navigate, because sometimes the difficulty that we have, I'm not talking about Flower, talking in general, of dealing with different version, and from some particular model or experiment you need to have CUDA version 12. In another experiment, maybe the way we handle the virtual environments, if we can use PyEnv, we can use I don't know, poetry, UV. These kind of things can be really useful because there is a large interest in IML from Python engineers that could be actively contribute also in improving the developer experience, but also as DevOps, as a experiment and try to deploy these things in VM in a safe way in a VM by following security standards. I think nowadays everyone can contribute. That was the great thing about Flowers, the inclusivity about the community. So I really feel welcomed to give my point of view despite not being in the field. So that's something that Flower already did really well in improving the developer experience. And also thanks Jan, also to you, because you suggested me the Flash attention V2 and other many other things that you are being really helpful for this challenge.
Cool, thanks. What would be the next submission in your mind?
Maybe working together on something. Let's see. That could be maybe another small model. Yeah, but I would like to iterate also with the community and give also some space for the people to iterate over the baseline submissions that we have and try also to new models, new techniques, new things, and then keeping everyone in the loop thanks to the Slack channel and the community.
Maybe something for the finance leaderboard would be cool to see.
Yeah. Well, thank you very much, Massimo, for the amazing feedback and the presentation as well.